Please welcome Snowflake co-founder and president of product, Benoit Dashville.
Hi, good morning, everyone. I'm really happy to be here in Las Vegas with you all. And I hope you are enjoying Snowflake Summit like I do. Yesterday's keynote was amazing, right? So, since the beginning, our vision with Snowflake was to make the Snowflake Data Cloud really the best place to bring all data together, making data easily accessible and actionable to really everyone. And our journey began in 2014 when Snowflake transformed the landscape of data analytics in the cloud. And by decoupling storage and compute, Snowflake offers virtually unlimited and potentially unlimited scalability. But we didn't stop there. 4 years later, we further eliminated data silos by enabling direct collaboration within and across organizations, even when the data is located in different geographies or clouds. And now, all this innovation has come together to fully disrupt application developments. And really, this is the new frontier, making the Snowflake Data Cloud the best place to build, run, distribute, and even monetize a new breed of applications. And these applications have data at their core. They are data applications. And whether you are building a new data pipelines, training ML models, creating cutting-edge Streamlit apps, or developing full-fledged data applications, today, we are going to show you why the Snowflake Data Cloud is the unrivaled choice for building and innovating. And there are really 3 key reasons for that. First, Snowflake offers one single platform that empowers you to build high-value data products from their data layers all the way to their user interface. Second, you have access to a vibrant community that can assist you in your development journey. And third, we provide you with resources to help you monetize and really grow. Now, let's dive in the platform. And at its core lies data. And this is really critical since the value of machine learning models and data applications rely heavily on the seamless and unsiloed access to all relevant data. And our platform prioritizes these aspects in 3 different ways. First, it supports all data types, whether it's structured, semi-structured, or unstructured data, like any documents, images, or even videos. Second, your code can access data from multiple sources, whether they are internal or external, including value data sets located on the marketplace. And third, the Snowflake platform is compatible with various table formats, including both internal formats and open table formats like Apache Iceberg. Our platform also offers a wide range of capabilities to power your data apps. And to achieve exceptional speed in executing data flow programs, the Snowflake platform implements many cutting-edge optimizations, like, for example, vectorized processing, micro-partitioning storage, auto-clustering, and many other serverless capabilities that further accelerate your queries and your searches. And if you combine that with our ease of use and our out-of-the-box performance, Snowflake data flow processing is really extremely fast and therefore extremely cost-effective. In addition to SQL, with Snowpark data frame programming, you can now directly leverage the same data flow processing using Python, Java, or Scala. And this really enables you to expand your options for developing data flow programs while at the same time leveraging the performance and cost efficiency we have built in our data flow engine over the many years. And this makes Snowpark a formidable alternative to Spark. You really should evaluate it if you have not done so. And coupling this with our cloud services layer guarantees secure and governed access to all data with high availability and almost zero operational burden. And finally, SnowGrid, our cross-region and even cross-cloud technology layer, further empowers developers to run and operate completely at a global scale. And yesterday, we made many groundbreaking announcements that significantly expand the capability of the Snowflake Data Cloud. And in particular, we announced our private preview of Snowpark Container Services, making Snowpark so much more powerful by enabling you to deploy and run your containerized services and even applications directly all within the Snowflake Data Cloud. And we also announced various public previews like Snowpipe Streaming, Dynamic Tables, Streamlit, and the Native App Framework. But of all these announcements we made, I am especially excited about Snowflake Native Apps. Because if you think about it, applications are really the ultimate way to unlock the full potential of data by making it accessible and actionable to really everyone. And I'm so excited about it that I now want to spend some time explaining how it all works. So application provider can now bundle application logic and associated data in a self-unit that we call an application package. And as application providers, you can quickly distribute and even monetize your app by just listing it on the Snowflake marketplace. And that listing is either private to your organization or really public, visible to any Snowflake customer. And once your app is published, it can then be directly installed on other consumer accounts. And once installed, the app running on the consumer account can access data from 3 different locations. First, the code of the app has direct and live read access to the provider's data, which was shared via the app package. Second, the install app can now locally also store internal state, which is hidden from the consumer account. And third, the consumer can grant the app read or write access to a subset of the data in his account. And this capability is critical for applications which are used, for example, to enrich consumer data by leveraging data or ML models which were embedded in the app package. And finally, the install app can be made to be fully interactive using Streamlit's rich visualization capabilities. And also, we are working towards making it seamless to distribute your native app to consumers all over the globe in any other Snowflake cloud region of your choice. And this is achieved by leveraging the Snowflake global and multi-cloud presence. Snowflake will transparently replicate your app package to any region where your app needs to be installed and executed. So that concludes native apps, and I hope you are as excited as I am about it. So Snowflake goes beyond just providing an amazing platform. We also recognize the importance of having a strong community that can help builders, really builders like you, solve problems and provide you with ideas that can really accelerate your development lifecycle. And with Snowflake, you have all been active across the globe in this incredible community. And you have been contributing in many ways, from local in-person events, user groups, or even online forums. And we also recognize the data superheroes, which are here with us today. Bravo. Yeah. And it's very important to acknowledge that these groups give a month of their time and effort to share their expertise and help the Snowflake developers get the best possible experience. Data superheroes, really on behalf of the community, thank you for your dedication and support. So the community is also great at making great contribution to open source developments. With Snowflake Labs, we open source internal tools, and we also contribute directly to many of the projects you use, such as Streamlit, Apache Iceberg, Apache Airflow, and Fist. And finally, there are the weekly challenges where you can develop your Snowflake skills. I want to extend a big thank you to Christopher and Mike, who created last year 52 challenges from a conversation at Summit last year. As you can see, with Snowflake, you have a strong platform and a very supportive community. And beyond these benefits, we go even further by helping you expand the reach of your work through the full power of the Snowflake ecosystem. The Powered by Snowflake program helps companies at all stages build, operate, and market their application on Snowflake. And to see some of those cutting-edge apps in action, join me this afternoon for the Startup Challenge final at the Data Hub. As you can see, yes. As you can see, we are dedicated here at Snowflake to help you continue to grow and build data applications that can potentially reach millions of users. Now, it is time to see a set of action-packed demos. And for these, please welcome Elsa Meyer on stage. Elsa, to you.
Thank you, Benoit. Now, for everyone here in the Snowflake community, you are in for a real treat. We are about to witness a story that may be familiar to many of you and your organizations. A story you will see come to life through the lens of a fictional company we call Tasty Bites. Tasty Bites runs a fleet of over 400 food trucks. And this is their fictional workspace and headquarters. They are so successful these days that they're facing 3 major challenges. Data is now being generated at much faster speeds. Their analysts and their ML teams are working in silos, and they're not having much luck getting key insights into the hands of the business. So how will they address this? Bit of a spoiler alert. Here's what the team is about to dive into. They're going to bring batch and streaming data together. They're going to bring SQL and Python together. And they're going to turn data into intuitive applications. We're about to see how Snowflake solutions, along with some friends, customers, and ingenuity, will take Tasty Bites from chaos to efficient growth. In our fictional scenario, Tasty Bites is actually holding a food truck festival right outside in the parking lot. So luckily, we have quite a few data experts here to help. We'll meet a few of them along the way, but let's first meet our core Tasty Bites team. All of them are real builders here at Snowflake. As it turns out, they're pretty good actors too. I'm Elsa, a community manager at Snowflake. But as you probably guessed, thank you. As you probably guessed, today I'll be playing the role of your narrator. I'll be showing up every so often to catch us up on where we are, and maybe even share some of those snacks back there. Here comes Felipe. Felipe is a lead developer advocate at Snowflake and an analyst in our Tasty Bites scenario. And Marie is a Snowflake Senior Data Science Specialist, and she'll be playing the role of data scientist. Let's meet our other two key members, familiar faces, no doubt. Snowflake's very own Dash. Dash is a lead developer advocate at Snowflake and will be playing the role of Tasty Bytes' technical lead. And Amanda. Amanda is Streamlit co-founder and Snowflake product director, and she will be acting today as product manager. I'll be back in just a few minutes, but keep in mind that everything you hear and see about Snowflake is all real and available for you to try as a part of single platform. Team, take it away.
Hey, Amanda. The food truck festival is so amazing, and I ran into so many people that I really wanted to talk to.
Yeah. Don't even talk to me about it. I am so hungry right now. I missed it because we had an emergency leadership meeting where our CEO has handed us a brand new project that we need to be ready to present on at the next board meeting in a couple weeks.
That sounds super important. What is it?
Well, you know how we've been brainstorming how we're going to empower our franchisee owners to increase their own revenue?
Of course.
Well, the data science team has actually given us a new proof of concept that potentially lets us give franchise owners data-driven pricing and promotion for their own trucks. It's a really cool idea for how we could drive more pre-truck revenue, but of course, it's just a prototype. And now the exec team wants us to have a plan ASAP for how we can roll this out to all of the trucks.
Okay.
Yeah, it's tough.
That sounds like a tough problem to solve.
The good news is I've looped you in as well. Actually,
good.
I've got a meeting right now with the data science team and our franchise operations analyst to figure out a path to production. You want to join and weigh in?
Absolutely.
All right, I
See
just
how
got to get a
can help.
snack real quick. All right. You want anything?
Water.
All right. Guys,
Ready?
sorry I'm late, had to skip lunch, but good news, I brought Dash with me to make up for it. All right, Marie, I hear you've built us a cool proof of concept. Can you fill us in?
Yeah, so I've managed to build an ML model that can accurately forecast demand based on promotion of a menu item. To get that, I had to bring together purchase transaction data, historical record of promotions, and cost of goods. Using these ML-driven recommendations, we can expect a 10% lift across all of our food truck brands.
Really, 10%? Well, I mean, that would be really impactful if we could roll it out, but obviously this is just a proof of concept. So what hurdles do you see to rolling it out? And actually, let me take some notes. I'll send them out afterwards.
Well, accessing and processing data of daily transactions from our 450 food trucks was not easy, as we're talking billions of records. So I have the transaction data coming in real time, but I also had to enrich it with the more static cost of good and promotion data.
Okay, so just playing that back, we obviously need a way for batch and streaming to come together. That it, or what else?
Exactly, and automating pipelines to reproduce the transformations I've created in Python to feed to models. We don't have the resources to make this a real service.
Yes, and obviously we can't build a real service for the franchisees without first making sure that we're solving the underlying platform and data problems. Dash, anything that we've actually already got on our Q2 OKRs about this?
Well, we only use the platform today for batch-oriented workloads and to support our SQL users. The data that Murray's talking about, that's generated at a much, much, much faster rate. And for now, we have separate infra to ingest all of that.
Yeah, as an analyst, I can tell you it's been great for SQL and batch, but I would also like to be able to use the inputs and outputs that Marie's science team is working on. But because all of that work happens in a separate platform, I'll never get to build on top of that.
Got it. So we've got a silo between our batch and streaming data, and also a silo between our data science team working in Python and our analyst and operations team working in SQL. Sounds frustrating.
Yeah, to be honest, we've tried to bring all these things together, but in the past, it's never worked.
Yeah, which is why our team has its own separate infrastructure, which does mean we end up doing a lot of manual work on our own. This slows down our ability to run new experiments and then ship the successful ones into production.
Okay, so let me just outline what we would actually have to put a solution in place. So in an ideal world, we're going to have a platform where you could access and transform streaming and batch data, and you could do it in either SQL or Python.
Yes.
Okay. And then I'm assuming we're going to need some way to move work between your two teams. And on top of that, we need to figure out how to get these data products actually into the hands of our franchisees. Dash, any thoughts?
Sounds awesome. Super complicated.
Okay, well, yes, we've got the high-level vision, but obviously it sounds like this is going to be hard. But we don't have a lot of time. We need to present on something at the board meeting in 2 weeks. So let's see if we can figure out at least a path to an MVP, right, that would make this possible. At the same time, I think we're going to have to start work in thinking about how we could actually deliver more of these data products to our franchisee and owners. I'm assuming that actually you probably could build a lot of data products for them, and that could be really impactful for the company. So we're going to want to figure out how we could scale that. All right, let me actually synthesize this up, and I'll send you guys the notes, and we can schedule some follow-up meetings.
Amanda, you should talk to my friend Rebecca. She leads the data science team at EDF.
Oh, yeah?
I'm going to send you an article she recently wrote, and I know they've built a lot more cool stuff using Snowflake.
Awesome. Well, I'd love the intro and to meet her, and I'll take a look at this article while I eat my lunch of mango pineapple mix.
Well, I better get to work. I'll see you guys soon.
All right,
See you guys.
see ya.
I'll bet a lot of you can relate to what's going on here. We know that Tasty Bites teams have a few challenges to solve. The data they need is coming in at different speeds. Their analyst and ML teams are working in silos. And the business teams, they need their results yesterday. We know, does this sound familiar to you guys? Anyone? Raise a hand. All right. The good news is that this team here is totally up to the challenge. So Amanda reached out to Rebecca, who leads a data science team at a company called EDF. EDF is a real Snowflake customer and a leading energy supplier out of the UK that's already overcome the kinds of challenges that Tasty Bites is facing today. Can Rebecca give our team the jumpstart they need? Let's find out.
Rebecca, it's so nice to meet you.
Hi, Amanda. Great to meet you.
Yeah, thank you so much for taking the time to meet today.
No problem.
I was just meeting with Marie, who I think you know, and we've got a problem internally that we're trying to figure out about our platform, and she said you'd actually built something similar, so I'd love to learn more.
Sure, no problem. Where should we start?
Well, let me give you a little background on the task that we're trying to accomplish. A key to our success at Tasty Bites is increasing sales per food truck. We think that we can do that on low demand days by actually sending out optimized pricing and promotions to each of our trucks. But we really aren't set up to deliver those insights directly to our franchisees. We're going to have to overhaul our entire data platform in order to deliver this. And I'm not sure if this is resonating at all, but I would love to understand the problem that you were trying to solve and see if there's any overlap.
Yeah, sure. Well, that definitely resonates with me. So this winter, the UK government set out to incentivize people to use less energy during peak times. This was a response both to growing gas prices and also the potential for a shortage of gas, which could have turned into an energy blackout. To help address this, the data science team asked a group of customers who had smart meters to opt into a program that would ask them to reduce their energy, and then we would reward those users for reducing their energy when prompted.
Clever. Yeah, and that's great, and thank you for doing that work. That sounds really impactful. I bet that you had to turn it around really quickly, though.
Yes, it was very fast in that we needed a working solution in production within just 4 weeks. And what made this particularly challenging is that we were dealing with smart meter data. With this data, we had a meter reading coming in every half an hour from every customer, which is billions of rows of data, which we had to process really quickly. And because this includes customer data as well, this all had to be managed and processed in a really secure and governed way. And I'm really glad that we were using Snowflake and Snowpark when this happened.
Well, tell me more about that.
So before, we were dealing with really siloed infrastructure that our data science team had to manage. And to use Python, we were moving large amounts of data from the data lake in Snowflake to Spark clusters. And these were really difficult to scale, so it could take many months for us to move our experiments into production. Now we have a platform that's helped us to scale from delivering just 3 products per year to delivering 12 per year.
That's awesome, and that sounds very similar with what we're struggling with. I'd actually love to look at your new infrastructure if you wouldn't mind sharing it.
Absolutely. So here, what you see is data coming into Snowflake, which serves as our data lake to securely store a wide range of customer attributes. And to streamline the data processing, we started to use Snowpark for Python. This allows us to do all that large-scale processing without having to move and manage that data in separate environments. And because the syntax is really similar to PySpark, it was really easy for our data scientists to pick it up. And then to streamline the path to production, we've built out an environment for discovery. Here, our data scientists could use Snowpark to do all our experimentation and then quickly move that into production.
Well, that sounds really straightforward and quite elegant, but how long did it take you to actually build it?
Well, we started with an initial proof of concept. This took just 2 weeks. Then, after that, we took an iterative approach to development with the aim of getting working tools into the hands of data scientists for really fast feedback. We were able to release our first environment, which was our discovery environment, to data scientists just 2 months after the proof of concept. The fully automated platform with all the production environments in place was made available in December last year. So in all, it took just 5 months for us to develop the entire architecture.
Wow, I mean, that's the dream, to be able to release iteratively like that. Once you complete a product, though, how are you actually distributing it and getting it into the hands of people? We also have to do something similar with our data products for our franchisee owners.
Well, to share these insights with our operations and marketing teams, our team needed a really interactive way to consume these data science machine learning-oriented products. The existing BI solution we had wasn't really suited to this task, so we started to use Streamlit in Snowflake to build interactive apps. And the best thing of all is that our team didn't have to worry about any of the infrastructure behind these apps. Because, again, any infrastructure we'd have to manage would slow down on our ability to deliver on new products. And because all the data is under the same governance within Snowflake, anyone that had access to this data automatically had access to the Streamlit apps.
Wow. That sounds really impactful. Can you tell me a little bit more about what it's like to collaborate across groups right now? One of the things that we're really struggling with is just the silos that we have internally, even between our own teams. I'm wondering if this new platform has changed at all how you collaborate.
It has. It's really changed the morale of the team, both in the way we work day to day, but also how we work with the rest of the business. The experience of being a data scientist in the old platform was really not great, and it's vastly better now. We didn't really have a great developer experience before. It was really hard even to get started on a project because we'd have to wait days to get hold of the data that we needed before we could even start work. Whereas now, we've got everything at our fingertips. And because of that speed at which we can now deliver on products, the business is always excited to work with us. And what that means is that we get more and more interesting projects to work on.
That's awesome.
And as Joseph, our data science product lead, would say, this team can build solutions fast, and the business are always excited to come to us to help solve their problems.
Wow, well, this has been a really useful conversation and a very inspirational direction for us as well. I'm wondering, would you mind if I follow up to get some tips on how to use Streamlit?
It has been an absolute pleasure to speak to you, Amanda, and I would love to follow up to share more of our experience with Streamlit.
Well, thank you. I actually didn't get lunch. I'm going to go see if the burrito bus is still here.
That sounds
great. Want to come with me? All right.
Thank you, Rebecca. And thank you for being such a trusted Snowflake customer. So, the first thing the team needs to do is figure out how to bring batch and streaming data together. Let's get into our first round of demos highlighting some really cool features. Snowpipe streaming for real-time ingestion, and dynamic tables to deliver declarative and continuous data pipelines. In this demo, we're going to meet a new character, James, who is a director of product management at Snowflake for pipelines and storage. Let's bring Dash out to kick off our demo.
All right, we got some water. How's everyone doing today? Excited? Awesome. So what I have going on is I'm ingesting some order transactions data using Kafka Producer, right? And I've set the ingestion method to Snowpipe streaming right here. What I've also done is set a Kafka topic to orders, as you can see right here. And then I've mapped the Kafka topic to a streaming orders raw, which is a table that's going to get created automatically because I've set this attribute to true, which is amazing. So I don't have to know the schema beforehand. I don't have to pre-create the table. It gets created automatically, right? So now let's look at the data itself. For that, I'm going to go over to Snowside. First, let's look at the data structure. Here are columns being ingested into the table. And now we're going to look at how many rows I've got in the table. 29,000, not too bad. We can do some analysis with the sample size, right? Now let's look at the actual data. Here we go. And then you'll notice that the first column, called record metadata, is a semi-structured column. And now let's see how easy it is to actually extract that value using a colon notation. So the colon notation looks like this, and I'm going to run this query, and we'll see the values coming out. Here we go. As you can see, the format is the epoch format. Now I'm going to use some SQL functions like hour and to timestamp to convert that into an hour value. Okay, so that's what we're going to do right here. There we go. So now, using this, it's going to be really easy for me to join the data so that I can see values per hour for total cost and total sales. For that, I'm going to run this SQL right here. Will take just a couple seconds. Boom, there you go. Now, the last piece of the puzzle here is I need to decide whether to use streams and tasks or dynamic tables. Why? Because of incremental refreshes, which is super important for this type of analysis. And I think I just saw James at the Food Truck Festival. Let me see if he's still around. He can probably help me out because he knows all about that kind of stuff. Hey, can you check if James is still around? Oh, hey, there you are. That was fast.
Hey, Dash.
How's
It's
it
nice
going?
to see you.
You too.
So what are you working on?
Well, so check this out. I have low latency data ingestion working really well using Snowpipe streaming, right? Correct. So now I need to combine this data with some static tables I have. And I'm trying to decide whether to use streams and tasks or dynamic tables.
That's a really good question. I'm glad that I was here, and I'm happy to help.
Me too.
So to keep things easy, there's really two considerations that you want to think about. The first consideration is about control. In this case, how much explicit control do you want over the orchestration and the logic of this pipeline?
Okay, so not much because I'm just looking at my notes. I'm more worried about enriching the streaming data in real time.
Ah, real time. Everybody always says they want real time. And the speed of the refresh and whether that frequency is going to change is going to be the second big consideration. So for this particular use case, is your decision-making going to change if the data is refreshed every 60 seconds versus every 5 minutes, 15 minutes, hour?
Well, really good question. So for what the team is working on right now, there's not much they can do within, say, minute windows. But in the future, we might create applications for our food truck drivers, which is when it might be super important.
That's really cool. That's a cool use case to keep in mind. Here's what I would say. So when choosing between streams and tasks and dynamic tables, streams and tasks are imperative. They give you a lot of that fine-grained control over how things run, and they're really good for complex pipelines that are going to run, and the frequency or the speed's not going to change over time. Dynamic tables are declarative, and they're designed to automate away a lot of the complexity of doing that incremental processing that you mentioned. And to give you an example, if you want to shift the speed of that pipeline in the future, all you need to adjust is just a simple parameter, and Snowflake takes care of the rest.
Yeah, since we're moving towards more frequent refreshes, I don't really want to be manually defining the whole orchestration. Sounds like dynamic tables is a good fit. What do you think?
I think dynamic tables would be a really good fit for this. And in the future, when you do onboard that use case, and you want to go from refreshing maybe every 15 minutes to every 60 seconds, all you have to do is update the one lag parameter, and Snowflake takes care of the rest.
That's awesome. Thanks for the advice.
Absolutely.
It was great seeing you.
It's good seeing you, too. And I actually just wrote a blog on this. I will send it to you so you can get buy-in on this approach.
Absolutely. I'm going to bookmark you right now.
Always nice seeing you, Dash.
Yeah, you too. All right, so we've got the ingestion going. And based on what James told me, I'm going to create a dynamic table. Now, this is as easy as writing this SQL statement right here. It's a DDL. And we already have the logic because I have the SQL statement that I'm going to copy and paste, and we'll have a dynamic table created. Copy this. Let's go ahead and run the SQL. There it is. So now I'm going to do a manual refresh so that we can review the data that we've just created using the dynamic table. So for that, I will find the SQL that I need to run. Give me just a second. right here. And now let's look at the actual data. Boom, there it is. Awesome. Guac and roll. Tasty bites.
So, we've handled the matter of bringing batch and real-time data together using Snowpipe streaming and dynamic tables. Now the team is ready to tackle the next thing, bringing Python and SQL together to strengthen collaboration across data teams. Dash is about to take a stab at a proof of concept using Snowpark. In particular, using the new Snowpark ML APIs for feature engineering to accelerate code developed by Marie, our data scientist. In a few minutes, to get help with that, we're going to introduce a new Snowpark expert to the story, Etta, who in her role as Principal Data Cloud Architect has helped dozens of customers get the best use of Snowpark.
Okay, so I know that we can use Snowpark for feature engineering and for the features that Marie will use for training the model. I've gone ahead and written some code that I'm going to walk you through right now, and we're going to do a bake-off. Who's ready for a bake-off? So the first thing I'm going to do here is import all the libraries I need for this bake-off, including Snowpark, which you see right here. I'm going to run this cell. Shouldn't take that long. And then next, I'm going to establish a secure connection to Snowflake from my notebook. Now, here are all the feature columns that we're going to use to pre-process. I've also defined the table name, and then a couple of other constant values for the total rows we're going to process for the bake-off. Okay? Now, here's the bake-off. You guys ready? First, we're going to use, thank you, scikit-learn's standard scalar and pandas data frame processing 2 million rows. So I've run this in the past. It takes about 30 seconds. So we'll see what happens. It's a live demo. So I have some jokes in my pocket. I'll pull them out if it takes longer. But I just want to highlight that I'm actually using pandas and also scikit-learn. If you see the highlighted code right here, and then here's the 2 million rows I'm passing in, and then here's where I'm doing fit and transform. And we're going to look at the first 10 rows. So 30 seconds, boom, there you go, on point. Now, let's see how long it's going to take Snowpark ML and Snowpark data frames not only to process 2 million rows, but 200 million rows. Who's ready? All right. Make me proud, make me proud. Look at that. Wow, look at that. How amazing is that? Someone do the math for me, the difference. It's awesome, right? Cool. Now, I need to figure out how to operationalize this code. Super important, right? And I think I know Etta. She was at the food festival. I think she might still be here. It'd be awesome if I can ask her.
Hi, Dash. What a cool event with the food trucks today.
I know. Amazing. Great to see you. So, here's the thing. I know you have to go, but I read your blog on Snowpark store procedures. How much of that content is being used in real world? Can you please share some details?
Sure. I literally do that almost every day with some of the biggest brands in the world. I've been building with Snowpark with customers and partners, and we really help them scale their pipelines and ML workflows in a more efficient way for almost a year now. At Snowflake, my team and I build many industry solutions with our customers and partners. Some of the most recent solutions we've been working on are quant research in financial services, advanced personalization in retail, and pharmaceutical supply chain resilience in life sciences.
That makes me feel much better. So here's my question. I did a proof of concept using Snowpark ML just now, and for data science team to use for development. But I need to start thinking about best practices to operationalize the code.
Yeah, of course. Stored procedures is definitely the way to go. Your Python code typically does two things. First, it can be used for data preparation operations such as grouping, sorting, or removal of duplicates, which can be done with Snowpark data frames. And then, for more advanced feature engineering, the Snowpark ML library is the way to go, as you see it in your proof of concept.
Right.
Second, it can be more advanced logic, such as machine learning model inference, that can be executed as a function. ML inference is one of the examples, but it could be also more advanced business logic that you embed in your data applications.
Okay, so I'm with you. So can you share more about the two options that you just mentioned?
Sure, of course. Let's start with the data preparation operations. Many times I see either Pandas or PySpark used for these operations. Pandas is really easy to use, and it's very common, especially among data scientists, but it lacks scalability. PySpark, on the other hand, which I have worked for years in the past, can be more scalable, but Spark clusters are rather painful to configure for performance and optimal performance and cost. For both data preparation and feature engineering operations, Snowpark gives you the best of both worlds. Easy to use at any scale.
That's cool. Based on the test that I just ran, I had a good set of steps for, say, data preparation. But how should I think about running ML models that use Python packages like scikit-learn and XGBoost?
Really, really good questions. Let's dive into the custom function side of things. Using the Snowpark ML library, data scientists can quickly train their models in Snowflake. Once trained, the model can be deployed as a user-defined function, or UDF, to do model inference. The whole process, from development to production, is pretty seamless because Snowflake has an integrated repository of Python packages from Anaconda, which allows you to run your custom code using XGBoost or any other popular package very easily. With their integration, teams get access to vetted versions of the most popular Python packages in order to prevent software supply chain attacks from malicious packages that could attempt to corrupt or exfiltrate enterprise data over the network. This alone mitigates a lot of security review hurdles many data science teams encounter as they try to get their models into production.
Yeah, that is super important. I'll let the data science team know.
Yes, and I know you're not quite there yet, but once you start using UDFs for model inference, I recommend you to check out something else.
So much suspense. What is it?
There's an excellent quick start created by my team, and in this quick start, you will see tips and step-by-step instructions on how to get the most performance with your Python code. For example, you can scale out model inference to achieve 30 to 40% performance gain by just using vectorized UDFs.
I'll definitely like the things that make things run faster. So I'll check it out for sure. So I know you have to go, but let me, tell me if I got this right. So I need to remember to use stored procedures to schedule and operationalize my data pipelines. And I have to look into user-defined functions for writing custom code for inference. Is that right?
You got it.
Nice. Thanks, Etta. Super helpful.
Okay, guys, that food truck festival is totally lit. I couldn't get enough of the donut holes, so I brought a few hundred more. Grab a box and share it with those around you. We are all about sharing here at Snowflake. And there's more. We've hidden some tickets under your chairs. If you're one of the lucky few, just take your ticket to the Manufacturing Chalet in the Snowflake Industry Pavilion at Basecamp East to claim your prize. Okay, so back to Tasty Bites and our demo. Before the break, the proof of concept for Snowpark went really well, and Dash is super excited to see the data science team try it out. So the team has found a way to bring batch and stream data together. And now there's a path to bring SQL and Python together. The only thing that would make this even better is if they could give more power to the analytics and data science teams. And I have a hunch that using ML-powered functions and Streamlit in Snowflake is going to do just that. Let's see what the team is able to do.
Hey, Felipe, is that a burrito you're eating?
Yep.
You must be so happy.
Yes, well, I'm not really happy. I really wanted to have lobster mac and cheese for
How come?
lunch.
You love burritos.
Yeah, but I wanted to have a lobster mac and cheese for lunch, and they ran out of it. But don't worry, I have a plan.
What kind of plan?
Well, we have all these food trucks, we have all this data. We can help the food truck owners forecast the future, their future sales. If they can see the future, they can buy all the ingredients they need, so they never run out of mac and cheese with lobster and whatever else their customers want to buy. Also, with a good forecast, they will avoid buying too many ingredients because we don't like waste either. And this is the perfect way to show off the new native forecasting functions in Snowflake.
Okay, let's do it. How do we get started?
Cool. So first, let me create a summary table with all the purchases by hour on each truck, on each location. This is my three-table join. I can create a table. And then just to focus on the lobster mac and cheese, on track 184, this is my results, and we can see a cute visualization. Now, how do we extend this timeline into the future? We need 3 steps. 1, we can create a view with this timeline. 2, we can use the new forecasting function to create a model. And then we ask the model to give us a forecast. Let me show you. This is me creating the view. This is me just creating the view. Then I need to add zeros. Zeros are really important when we are building a model because we usually don't have those in SQL. But then these rows with 0 will tell the model that the food truck is closed at that time. And then this is how I create the model. It's Snowflake ML stateful forecast. I give it the timeline, our view. I give it the column with the timestamp, and I tell it this is the target that we want to predict. And to see my forecast for the next 160 hours, I just call the model and ask 160 more periods.
You want to buy the burrito?
You can have a burrito. I brought one for you.
The black beans?
Yes, it's a veggie.
Thank you.
Of
Appreciate
course.
it.
And here are my results.
Oh, that's
that was-
beautiful.
I know. Look at this.
So does the forecast take into account that the food trucks stay closed at night?
Yes. So you can see here that our forecasting function detected automatically the seasonality. It's daily. It has the breakfast period, then everyone comes at lunch, and then the busiest period is at dinner. And you get all these beautiful zeros approximately when the food truck was closed. And as an extra bonus, we also get a upper bound and a lower bound for our predictions.
Cool. I'll take these forecasts to the food truck operators.
Not so fast. There's so much more that we can do. Like, we are using sales data to forecast sales. But we could have sold a lot more if we had not run out of it. For that, we should detect anomalies in the data. That's another new SQL function that we can talk about later. But let's go back to forecast. There's so much more data that we can use. What if people buy more lobster mac and cheese when it's rainy, or more ice cream when it's hot? If we know the weather forecast for the next week, we should be able to use it for our food sales. And then we can prepare our owners for any kind of week.
That would be pretty useful. But the locations that are planned for the food truck probably also have a big impact, right?
Correct. Location is another exogenous variable, and we can play with that. And we can play also with multiple series. So For that, I can create a new time series, and this is my timeline with the food and the location for all the food items, and then I'm extracting a view, including the location only for the lobster mac and cheese, combo fried rice, and the New York dog to do multiple series. And of course, I add all the zeros. And then I use the same function, but now I'm giving it a series call name. These are all the series we want to predict for. And because the view has extra columns, those are exogenous variables that can be used on the forecasting tool. Now, with that view created, I can call the new, we created the model. Now I can create the forecast. And for this, I created a different view. This view needs to have all the timestamps that we want to predict into the future and the exogenous variables that we want to predict for. I created that view here, and let's ask for the new forecast. Let's give it some seconds. You can eat a burrito in the meantime.
I don't think I have enough time. This is going to run so fast.
Correct. I surprised you again. So here you can see the chart. 3 different time series, combo fried rice, lobster mac and cheese, New York dog for each of the different locations.
This is awesome. I mean, I would never have thought that this would be possible. And now you can make sure the right amount of lobster rolls for the next festival.
Yes, sir. I'm happy, and I think our customers will be super happy too. We will get to experiment a lot more with these functions, but this is my last forecast for today.
Oh, wait. I just got a text message from Marie. I think she wants us to show us something.
Let's go check.
All right.
Marie.
Hey, Marie.
Yeah. Hey, Dash.
How's it going?
Great. So, you know how my team uses notebooks to build models and do analysis, right?
Yes.
Well, a typical request came in from the Guac 'n' Roll brand manager, and he gave me a spreadsheet with his pricing for the upcoming month and asked me to forecast demand with it. What we have here is the recommended prices for one of the menu items that comes from our model. I imported his pricing, and then I used that model that I had deployed in Snowflake to calculate the total weekly demand lift and the total weekly profit lift, and that's forecasted to be a 6% lift, so that's pretty good. And then I plotted the demand by day of week. Cool. Now, of course, once I showed him that, he had a lot of what if, what about questions? What if we reduced the promotion a little bit? What if we added a second one? What if we used all the recommended prices? And I said, I can't answer that right now, but let me think about it. I think we can solve this. So I went away, and that's when I saw your note from your meeting with Rebecca about Streamlit. So I went into Snowflake, and with just a few lines of code, I put together the simple Streamlit app where you can navigate to a brand and then navigate to a menu item. So I'm going to go to the Not the Worst Hot Dogs brand, and then the Chicago dog. And here you could see the recommended price. So I thought this would be a good way brand managers could at least get the recommended prices when they want them. So I sent a message to the brand manager. We hopped on the meeting. And I want to walk you through how that meeting went because it was a really cool experience.
All right, I love a good behind-the-scenes story.
OK, so the first thing, after showing him this, I wanted to show him how easy this was. So I could make changes to the code over here. See that balloon? I'm going to change it to a truck. And on the right side, ta-da, you can see a change. So right away, we can see right away we can see the application change and interact with it. So I said, because of how easy this is, if you have any ideas of how this application could work for you and be really useful, maybe we can iterate through it right here and make it happen. And he had an idea. It was a great idea. He said, well, what if we use this not just to view the recommended prices, but we actually used it to set our pricing? I said, OK, let's try and figure that out. First thing we had to do is make this data frame here editable. So we're going to switch it from a Streamlit data frame to a data editor. And then once I do that, we should be able to have that update. And then now we can edit this price. So I'm going to edit it to one of the recommended prices for one day here. OK, great. So we can adjust the prices. But now we need to capture those changes. So I'm going to capture it in a data frame called set prices. and I want it to be a Snowpark data frame, so I'm just going to use the create data frame function here. All right. So now we can change the data, we can capture the data. Next step is to be able to save the data and submit it. So we thought, how about add a button? So we added a Streamlit button that says update prices. And then when that's hit, we're going to save that data frame back to Snowflake. And we're going to do this by appending it so that we can submit it for multiple menu items.
Makes sense.
Smart. And the table will be final pricing. OK, so now, let's see. Did this work? Will the button appear? There's the button. We can hit update prices. Now that change is made, we're going to save it back into the table in Snowflake. And then the other thing we also added, because it's kind of hard to tell if anything happened when you click that button, so we added a nice Streamlit info message that says updated, so we know it happened without error. So now we can submit that, do it again, and it will let us know when it's successfully saved into Snowflake, and it will say updated. OK, is it going to sit? Well, we'll get to see it again later. So the next part of this demo is, or the next part of this meeting, which was a really cool part. He said, OK, this is great. I can update prices. But what would be really nice if I could try different prices and see what you had in your notebook so I can know the demand of the different prices I'm trying. And I said, yeah, that makes a lot of sense. And I think we can just copy this over because this is Python, that is Python. So let's copy over where I'm calling the user-defined function here. So right under where we change the prices, I'm just going to paste this in. What I'm pasting in is where I define the features for the model, where I use that user-defined function to call the model and get the new price demand, where I calculate the two metrics we really care about, the demand lift and the profit lift. And then I'm just going to make these metrics. And he said that he would like the two metrics to be side by side. I thought changing layout and playing with layout was a little intimidating, but as it turns out, super easy. Again, so just use Streamlit columns, and then assigned one metric, demand lift, to one column, and the other metric to the second column. OK.
Amazing.
So let's see if that submits here. No typos. And what we will see is that for, columns.
Yes.
Wow.
Columns, OK.
All good.
Columns, live demo, live typing.
Super easy fix.
It's good it's a small group I'm doing this in front of.
Right.
Yeah. So that.
That's cool.
So now what we see is in the background, this change we made is running through that UDF and updating on the fly to get our weekly demand and our weekly profit lift, which is 6%. Not bad. So any guesses what was asked for next?
I mean, I love this, but what about visualization?
Oh, yes.
Gotta see it in the chat.
Oh, yes, the data analyst loves the visualizations. So, yes, he asked for a line chart, which in Streamlit, again, is really easy. It's just like any other object. And we wanted to look at our demand by day of week. So on the x-axis, we have day of week. And then on the y-axis, we are going to compare our new price demand that we want for the upcoming month with the current price demand, which has been set in the current month. See any typos, Amanda?
It's OK, no one's here.
No one's here. It's fine. All right. So now we submit that, again, calling through the user-defined function, get that total weekly demand lift, weekly profit lift, and then we have that nice chart, and you can see that spike in demand on the day we change it. So now what was left was to share it.
So do the brand managers have to look at the code when they use it?
It's a good question, but no, they don't at all. So what's really cool is I can share it to the role. So I'm going to share it to the brand manager role in Snowflake. They have view-only access, and I just share through this link. They log in, and what they see is this interface here. And so at the end of the meeting, what we did is I had the Guac and Roll brand manager walk through it as himself. So he navigated to the Guac and Roll brand, and then we selected chicken burrito, which is the same menu item we were looking at in the notebook. To start, he thought he wasn't ready to commit to all the recommended prices, but he said, OK, I can start with just the weekend. That's a good start there. So he changed Saturday, and then he also decided he would change Sunday as well to have a full weekend-long promotion. And you can see now we're going through that user-defined function. We're calling that model on the fly, getting the results, and we can see a predicted 20% lift in demand and an over 17% lift in profit. Yeah, it's pretty cool. Yeah. And in our chart, we can see previously there was a bit of a demand slump on the weekend, and now that's right up, and we can update those prices. So just like that, I was able to collaboratively build and deploy an application with one of our brand managers to create something that he could use to set prices and get ML insight.
That's impressive.
Wow. It's hard to imagine. We were all working.
Yeah. Yeah.
I'll repeat. Wow. It's hard to imagine. We were all working on the same data to do all of this. And to summarize, just to summarize, we got the ingest and refresh of data on a schedule that makes sense for everyone, and also it was cost effective. We now have SQL and Python that is bringing our data teams together to collaborate more. And what else? Felipe and the analyst team can now use their data knowledge to drive their own insights using ML and SQL. And lastly, data science teams can now easily deploy these apps. What a day. What do you think, Amanda?
Incredibly impressive, guys. And you've done the most important thing, which is you're going to make me look really good in front of the board. And I didn't even have to write a single product spec. So I'm really excited about this, and I'm actually really excited about the app. It's got me thinking that there's maybe something that we could do here that would actually be really great for just our vendors, right? Not our franchisee operators, and possibly something we could even sell to them if we wanted. Actually, I think we're at time. I'll catch up with you guys later. I've got another meeting. And my meeting's in here, so I'm going to kick you guys out.
All right.
All right. We'll see you later.
So much has been accomplished up here. Let's recap. The data science team just built an app using only Python. The analyst team can quickly experiment with ML using familiar SQL. The possibilities seem endless, and there's more. Amanda is really excited about taking this new app to even more users. And as we've learned, the community is a very powerful resource. Christopher works at DTCC, a financial services leader at the center of global trading activity. They process quadrillions of dollars of securities transactions on a daily basis. Let's hear how Christopher has been building and sharing apps in a secure way with customers using the native app framework.
Hey, Amanda, how you doing?
Hey,
Nice to see you.
Christopher.
How's everything?
Thank you so much for taking the time to meet me today. So
Oh, no,
lucky
my pleasure.
everyone is here at the Food Truck Festival. I was just reading your blog on how you and your team are using Snowflake to distribute your applications, and I'd love to learn more.
Yeah, great. I'm happy to help. Tell me more about your app.
Well, my team just showed me a really cool app that they made with Streamlit and Snowflake, and it has me thinking about what we could do to distribute it and maybe even monetize it. And then your blog mentioned you were doing something similar, so I'd love to learn about your journey.
Yeah, absolutely. First, let me tell you a little bit about DTCC. We're the premier post-trade processing company in the financial services industry. We pride ourselves on being a risk management company, a data company, and an innovator. We process hundreds of millions of transactions on a daily basis, valued at over $2.5 quadrillion annually. We've been using Snowflake since 2018, and we started as a lot of firms do with our data warehouse workloads, our data lake workloads, and just generic SQL workloads. But as the Snowflake platform has evolved over time, as Benoit mentioned earlier, DTCC has evolved with it. And what we're really excited about now is that next step in the evolution, which is the native application framework.
That's impressive. I don't even know how many zeros are in a quadrillion.
It's 15.
15, all right, all right. Well, you mentioned the native app framework. Can you tell me a little bit more about that?
Yeah, when you think about the way that financial services traditionally processes their data, it's really batch-based exchanging of data, but we really want to give more power to our clients. We want to have that power in their hands, and we want them to be able to share both data and algorithms so that they can run not just normal workloads, but also hypothetical scenarios. In fact, I can walk you through the architecture. I think I sent it earlier on.
Oh, thank you. That'd be great. Let me just pull that up. OK. All right. So taking a look at this, it looks like there's 3 key components. You've got the data, the logic, and then the UI layer. All of that in Snowflake?
Yes, exactly. And that's really key here, is that you have that package of data, logic, and UX. And because you have the rich UX in Streamlit, it means, as the demo just showed, you don't need to have a specialty in UI development. You can use your existing data team to run your native applications. The other thing about the packages, which I find really fantastic, is we've invested in capability on the Snowflake platform. And so when this package runs on the Snowflake platform, we can leverage capabilities around security, deployment, and resiliency that already exist.
Awesome. That's really, really cool. Well, this actually sounds like it could be a really great fit for our data teams, and having that all packaged together would be really empowering, because our data team, they're not front-end developers. And I wonder if that's something that you've struggled with as well, like how they become application developers.
Yeah, I think it's been really well received by our team. And to be honest, the team, our data team, they're really motivated by impacting our organization. And they're even more motivated by impacting our clients and the financial services industry in general. So an anecdote that we were talking about yesterday is I have folks on the team, for example, who came from an Oracle DBA background, became a Snowflake expert, and are now running end-to-end applications within the native application framework. Amazing. In fact, in one of the sessions yesterday, if you saw, we actually demoed that application, and it was really well received by the team. So we see this as an exciting opportunity to really give that power to our data team.
That's really amazing, and it sounds like Snowflake has been so great for you and your team as well. I'm pretty sold that we should go down this route, but is there anything else I should know?
You know, we really think that both DTCC and Snowflake are going to have an impact on the financial services industry. And as DTCC grows and as Snowflake grows, we think that growth is going to be mutually beneficial for both parties. And not only that, we really feel that that benefit is going to extend to the entire financial services industry.
So cool. And I'm so excited that you were able to chat with me today and read me in on all of this. Would you mind if I actually share this diagram with my team and let them know?
That would be great, yeah.
Well, thank you so much. I can't wait to catch up with you later.
Perfect.
I'm going to go to the mochi truck.
Oh, my daughter will be jealous.
You want to get some mochi with me? All right, let's do it.
And that is what I call a mega project. With Snowflake, Tasty Bites overcame every challenge and delivered. And now they even have a path to distribute and monetize their work. With that, I'd love to invite Benoit back to the stage.
Yeah, that was amazing. That was amazing. And you only got a small taste of everything you can build with Snowflake today. So as you can see, I'm very excited about the future of app development with Snowflake. And the best is that you can get started now. And I want to extend a huge thank you to Rebecca from EDF and Christopher from DTCC. Thank you so much. And really, we really appreciate to have 2 Snowflake customers participating in our demos today. And also a special thanks to our demos team. This was amazing. So now with all of this, you guys should go build. Thank you, everyone. Have a great day.